Welcome back, friends. Today in this video, we are going to learn brief introduction about Eigrp and also configure Eigrp routing protocol in this video. Eigrp is also called as Enhanced Interior Gateway Routing Protocol. So this is a advanced version of Eigrp, which was obsoleted, and it was a legacy protocol. So with the invention of Eigrp, which was a combination of a distance vector protocol and link state, and hence this Eigrp was called as a hybrid routing protocol. The main important metrics to determine the path value includes bandwidth, delay, reliability, load, and maximum transmission unit, which is also called as MTU. Generally, the first two metric, which is bandwidth and delay, is used by default when you're calculating the metric for Eigrp. When it comes to reliability, load, and MTU, no point to use this since it is a variable component. And if you're trying to change on one side of the router, you will have to change the other side of the router too. So usually we use bandwidth and delay in common. We, we also have a metric calculation for Ergrp, and that is represented as 256 multiplied by bandwidth plus delay. Okay, so what is this bandwidth and delay? Nothing but 256 into the bandwidth is indicated by 10 to the power of 7 divided by the least bandwidth. So let's say BI. I'm just keeping that as a BI. So this is nothing but the least bandwidth of all the outgoing interfaces on the route to the destination network, represented in kilobits per second. And this delay is nothing but, let's say, delay in microseconds. So this delay is the sum of the delays configured on the interfaces on the route towards the destination network, and that is calculated in terms of microseconds. And we also know that there are hello messages, there are Eigrp messages that is commonly used for hello messages, update message, query message, reply, and acknowledgement. Okay. Ergrp has three types of table. The first is a neighbor table, which gives the information about routes that form the neighborship. We have topology table. This table indicates both the physical successor and the successor. Okay. And finally, we have a routing table. As the name indicates, it's a routing table. It includes the best route, and that is definitely the successor. And one more most important note here in case of ERGRP is that it can help in minimum 4 to 16 paths for load sharing. Okay. And also, it is possible that it can also help in unequal cost path load balancing. Okay. And that can be used even if you are using different metrics using variance. Let's also understand the basic differences between reported distance and feasible distance. Reported distance is the metric for the route as advertised by a neighboring router. Okay. Whereas feasible distance is the metric for a router from the local router. And this includes the reported distance. And you can find this using a command which is show IP Eigrp topology. Okay. So let's just take a basic example here. I'm just taking 3 homes. Okay. And we have Mr. Tom here and Mr. Jeff, and we have Jack in this house number 3, 1, 2, and 3. Okay, so now Tom is going to ask a question to Mr. Jeff that where is Mr. Jack? So how many homes do I need to cross if I need to reach Mr. Jack? So Mr. Jeff says that, okay, Mr. Tom, you need to go from my home. Mr. Jack is 1 home away from me. Okay. So for house number 2, this is the reported distance. Okay. From the neighboring route. So this is the neighboring route, and this is my local router. Okay, this is the neighboring router for whom I am asking a question. How do I reach Mr. Jack? So this is a neighboring route. I'm sorry, router. So from the neighboring router, the reported distance to reach the house number 3 is just 1. So reported distance is equal to 1. Okay, so Mr. Tom says, okay, I need to cross 1, 2 homes to reach Mr. Jack. So that's nothing but physical distance of 2. This is a feasible distance of 2. That includes your RD value within it. Okay, so feasible distance includes reported distance within it. Okay, so this is a basic example so far for reported distance and feasible distance. Let's conduct a small lab in order to understand the basic configuration about Eigrp. In this lab, we have taken one, two, three routers connected. So we have a serial connection between the router 0 and router 1. And we have router 3 over here. At the moment, I have already pre-configured the IP address with a subnet mask over here with the network 50.10.10.0 for /24, and same here, 24, 24, and 24 for the CIDI value. So we got 32.10.10.0 on this network here, and we have 80.10.10.0 over here, and 10.10.10. network on the serial interface between router 0 and router 1. So from the PC to router 0, I have configured 10.1 on this port over here and 10.2 on this PC with default gateway obviously 50.10.10.1. And um, for this port over here on the router, I have configured 192.168.1.1, and this is definitely the default gateway for my PC1. And we got dot 2 on this port over here connected on this PC. So our main task for today is we are going to configure the Eigrp with the autonomous number, which is called as AS number 100, and advertise the neighbors connected to these routers, okay, using the Eigrp configuration. Finally, we are also going to make sure that you can see if the router chooses the best path in case if you just shut down this interface, it will the packet can still pass from this PC towards this path from R0 to R1 and then connecting to this PC over here. So no matter you shut down this link, the traffic can still pass on with the best route available in the routing table. So let's get started with the configuration of Eigrp. So we need to go to configuration mode. We need to advertise 32 network, 10 network, and 50 network over here. And we will use no auto summary, router Eigrp with AS number 100, no auto summary, and advertise the connected network. So we have 32.10.10.0. We have another network over here, 10.10.10.0. Another network here, 50.10.10.0. Okay, so just exit. So we have configured Eigrp on the router 0. Let's proceed with configuration of Eigrp on router 1. Okay, let's advertise. I'm sorry, it's just getting translated. Takes some time. We will go to global configuration and say router Eigrp with AS number 100, it needs to be present in the same AS number in order to configure Eigrp. So let's choose no auto summary with network advertised here. Over here we have 1, 2, and 3 network to advertise. So let's advertise this network. So 192.168.1.1. And we have another network over here. That's going to be 80.10.10.0, 80.10.10.0. We have another network, which is 10.10.10.2, 10.10.10.2. Okay, so you can see over here that there's a neighbor is having a new adjacency. Okay, so the neighborship is formed. Let's configure Eigrp on router 3, and that's going to be configure and choose router Eigrp is number 100. And we got 3 more network over here that, oh, sorry, we got 2 network over here to advertise. So one is 32 that you see here. So 32.10.10.0 network. And we have 80.10.10.1 network. So network 80.10.10. Sorry, 0. Okay, so that's network that we are going to advertise, and say no auto summary, and you can see that it's just getting the neighborship details, and just exit out of this. So we can see that I have already configured the IP address on the PCs. So I have just kept 10.2 over here, with obviously the default gateway being 10.1, which I configured on this router. And we have 192.168.1.2 on this PC, connected to the default gateway, which you see on this port ending with 1.1. So now we are done with the configuration of Eigrp and advertising all the networks connected directly. Okay, so let's go ahead and try to ping this PC, and ping the PC from this path to the PC on the other side. So let's choose this PC and go to command and try to ping. So I'm trying to ping from this PC. So I need the address of this being the destination. So ping 192.168.1.2. Yes. So we can see that the traffic is being routed from the PC 0 towards the PC 1. But how is this routed? We can also identify how the traffic is being passed and which path is it choosing by using traceroute command. So if you want to try to see which path, so you can use trace route and go to 192.168.1.2, and we can see that it's passing via 50, 32, and 80. So it's taking the path from 50, 32, 80, and then 192. That's what it's just passing through. Okay, so we now can see that once we have configured the Eigrp, the traffic has taken the path from 50 and reached up to this 32 network, 80 network, and then back to 192. That's what we saw in our trace route. But what if we shut down this path? Okay, let's see what happens if we shut down this path. I'll just give the command no shut on this port and see if Ergrp still supports the traffic to pass from PC0 to PC1. Okay, so let's go to the router and we will shut down this port, fast Ethernet 0/0, go to configuration mode, interface fast Ethernet 0/0, just give the shut down command. Yeah, so you can see that the traffic is just halted there. You see a red mark over here, which means there is obviously no connectivity. So when we want to verify the routing table, you will see that there is no directly connected network. Let's verify that on the router. So you verify it using the command show IP route. You cannot see that 32 network anywhere. Yeah, you can see it's directly connected 10 network, which is this network. You can see 50 network, which is this network, which is directly connected. Okay, and the 80 network, which is nothing but the Eigrp. 192 is going to be Eigrp. That's what you see here. Okay, and obviously the 50 network over here. You can also verify using the command show IP Eigrp topology. You do not see that 32 network anymore in any of this. Okay. All right. So if you have a look at this command over here, the first part is nothing but the feasible distance. It is the same distance over here. And the value that you see here for 2810, this is your reported distance, okay? That is, when the traffic is passing via 192.168.1.0, it's going to take this reported distance from this path. Okay, so if you want to see, just go to this router. Okay, why am I choosing this router? The reason is because if you see here, it's connected via 10.10.10.2. So this traffic is passing via this 10.2, and hence I choose this router. And if you say show IP Eigrp topology, and that's what you see here for the feasible distance being 28160. Okay, so that's the value where you say 192.168.1.0 connected over here on this port here 10.2 with a feasible distance 28160. And that's going to be your reported distance when you check from here. Okay. All right. So now we have shut down this command, this interface over here using using shutdown command on this router. Let's verify how the path is selected and still the traffic is being passed from PC0 to PC1. So on the PC0, let's try to ping 192.168.1.2, and there we go. You can still see that the traffic is being passed even if you have shut down this particular interface connected. It's choosing this alternate way to ensure that you have connectivity. So if you want to say what are the hops that it's getting passed and which path, you can also use the command trace search, and you can Oh, sorry, not on this. Okay, you go to PC and say trace alert. Okay, and give the command 192.168.1.2 and enter. Okay, so this time it's taken the path 50, 10, and 192. So the path taken here is 50, 50, 10, and 192. Okay, so that's when this interface was absent. But in case if this interface was present, then it would choose the best path according to its routing table, and it's gone via this. Okay, so this completes the configuration about Eigrp configuration and its lab. We are going to learn in details about load balancing in our next videos. I hope that this video has been informative to you all. Please do not forget to hit the bell icon and subscribe. Thanks for watching. See you in the next video.